the ongoing struggle with the Linux laptop continues. Basically, just trying to debug something of it, trying to figure out how to get the this the screen sharing thing to do what I want. And sound check is done. Go set time. Go set a time for 3 hours. We'll go from there. Let me try and fix this. So, see you under. When HDMI connected. Oh gosh, I just flipped my screen. What on earth? Oh my goodness. I flipped my screen somehow. Oh no. I wish you could see what I was seeing right now. Oh my god, no. I might have to. Oh my goodness. Oh no, this is turned into hell. Hold on. Oh, thank goodness we got back. We got it back. Right, don't trust Google. It's wrong. Do I use render X render to mirror my display to HDMI? I'm gonna ask Rock. Come on, Rock, save us. To display to an HDMI output, use Xander. On Linux, you need to identify your primary display and the HDMI output, then configure them to show the same content, the same resolution possible. Here's a step-by-step guide. Yep, I've got that. EDP1 is the laptop screen, HDMI1 is the output, mirror displays. So Xander output HDMI1 same as. Okay. So let's try that. So render outputs. And mine is HDMI. Sorry, you can't see this, guys. It's not fun to watch. I'm suffering, but it's kind of funny. Same as EDP-1, and then dash mode 920 x 1080p. Let me see if that worked. Mm. Try to compare the two commands difference and see how I sort it out. Mm, not quite. Oh, there we go. Back to normal. Whew. I also managed to fix polybar last night, so that was nice. Yeah. Where do I add this for i3? Let's reload. Ooh. I didn't like that. There we go. Not quite filling the screen, is it? It's almost fixed now. Just trying to figure out why it's slightly not square on the desktop. I did notice that the screen isn't being used to its fullest thing. Hold on. Oh, I know. Hold on. Be back in 1 minute. we back. Let's get this thing sorted. Oh, come on. Fix this resolution thing and then we'll be done. We'll be ready to roll. Wasted too much time already anyway. Let's see how this one does. Whoops. Let's see if we got it now. Properties. Hey, we got it. Is that? Yes, that's spawn, finally. No. Right, I think we finally got it sorted. Hallelujah. So, let's add that to our thing over here. Oh, finally. So, fully fixed mirroring. Boom. Huzzah. There we go. Whew, that was a bit of an ordeal. Thanks, Grok. Quit this. Go to window 2. Shift this over to window 1. Window 1. Boom. Here we are. We're back. Finally. Now it's time to cook. Let me just check one more time. Sound volume thing. Yep. Okay, we're ready to cook. It's cooking time. Don't interrupt the chef when he's in the kitchen. Let's go. So, back to functional programming. Of course, we're on chapter 3. So we're not even halfway yet. Let's try and really lock in. Let's get we gotta finish pure functions. Let's get through. Well, let's try and smash it all out. But got 2.5 hours. Let's try and get through this. Let's go. Okay, so we're on challenge 1 of 3 in the pure functions part. So hopefully smash through this. So custom commands. Doc is a customizable new command. Doc is customizable. New commands can be configured to use whichever functions suit the user. However, the new commands are causing bugs in other parts of the application by mutating global values and and other unintended side effects. Fix the functions. Add custom command, add format, save document, and add line break to make them pure functions without side effects. Here are the reported issues. Add custom command is an input pure function, is mutating an input. Yep, so we have to make copy. Let me see if I remember. Commands copy equals commands dot copy. I think it's like that, and then it's like that. And then add format is an impure function that is mutating an input as well. So same thing here again. So formats copy. Don't know a better way of naming it, to be honest. Formats formats.copy, and then same with that. No, I can't do command D selection. Frustrating. Save document is an import function of mutating input again, so like it's all the same thing. So so docs underscore copy equals docs dot copy. Same thing here, so docs copy, and line break is a no-op function with a side effect. So this add line break, so which one are we? Just return line. Hold on, what was it doing before? Print line. Okay, so return, and then just run it and see what it does. Whoop whoop. Yeah. And then we'll submit. Yes, passed everything. Let's have a look at their solution just to see. Yes, identical. Wow, I'm really surprised. Totally identical. That's exactly what they did. Let's go. Right, number 2. Challenge number 2. Sort dates. So date times are infamously a pain in the neck for programming. The least of the programming. Whoops. I don't have the thing. Right, chat, let's cook. So, sort dates. Date times are infamously a pain in the neck for programming. The least of the list problems are the order of the year, month, and day of a calendar date. Some countries use day, month, year format, and others use year, month, day. Some insane countries. Wait, what's the list of insane countries? Date format in the United States. Oh yeah, there's only one. Pain in the neck. Falsehoods programmers believe about time. I like that. Shit. Funny. Use month, day, year because they want everyone else to be miserable. Assignment: fix the sort dates function. It takes as input a list of dates in month, day, year format and returns a list of the dates sorted in ascending order. So what's wrong with this currently? 3 failed. So sort. Okay. Format returns list of dates in ascending order. So what's wrong with this? So fail. So the input is that, the expected, and the actual is that. So it doesn't, puts them in alphabetical order, not in date order. It's going to be a tip. It's going to talk to us about like the sort option, but I don't know off the top of my head. A built-in sorting function might work better than the sort list method. Create some function to transform dates more easily to compare them with sorted. Right, okay. So it's not just a straightforward fill in the blanks example. So create some more function to transform the dates more easily, compare them with sorted function. So I guess try I'm going to call it transform date to sane. It's going to take a date, and just for now we'll return date, and then we're going to do sorted. It's got dates. Sorted, and it's got dates equals sorted. We're going to do transform date to sane dates. This is tricky. It's sorted wrong if I used it wrong. Iterable, the iterable first, then the function. Eh? So I'd expected one argument, but I got two. What? Create some function to transform the dates to more easily compare them with the sorted function. Eh? Okay, I'm gonna have like transformed dates equals map. We're gonna do transform date to sane dates. I'm gonna use that there. See what it does. The thing. Well, yeah, I guess we're just returning at the minute, aren't we? Stuff. So let me have a look at the spell book. Sorted. Hold on. Wait. No. Date. Nope. Python. Wait, what are these strings? Python convert string to date. So it's going to be date string. Then we're going to be date equals, and then try this. So I'm going to take date time, string time. So date string, and then month, day, year. Forget the seconds. Don't care about that. And then then we want to change it. So Python date to string. So the format doesn't really matter. And then so date, let's call object. Oops, and it's going to be date equals that. Date object. Let's see what this does. Not quite. Let's print out what dates are. So print transformed dates. Map objects. So if we put it to a list, be able to see it. Whoops. I like back. There we go. Transform dates. So if I print date like that, what do we get? Oh, the error's at a different spot. Hold on. So print date object. Whoops, date. Hold on, Python string to date. Might be getting the wrong end of the stick here. Takes a list of inputs of dates in the month year format, returns a list of the dates in ascending order. Just before I do that, let's print out date string to see what it is. Am I miss? Yeah, it's just a string. It's definitely a string, so I've not got that wrong end of the stick. It is a string. Hold on. I'm going to ask Rock. Use your brain. How do I convert a string to a date in Python? Whoops. I feel like I'm probably doing too much here. Takes two. Oh, I'm a dummy. I didn't read the error message. Takes two arguments as given one. Warp, warp, warp. Silly me. I was thinking way too long. So time data does not match format. Or you have to give it the day format. So percentage day. Whoops. Dash. Dash. Whoops. And was it percentage M? Is that right? Oh, there we go. Right, okay, I totally fluffed it up. Right now, got that back. Let's see. Right, I think I got it now. So all of them failed. Expected actual. Send to list transformed dates. See what we get. Put a message, see if it's there. Okay, so they are formatted properly. Yep. And then when it's sorted, expected actual. Do we even need to sort them? Hold on. Yeah, I do. Hold on. Dates copy equals dates dot copy actual. I got a feeling we're gonna have to do something like the reduce method. Map. Not really a map function. Right. So we get this right. So how to use Python sorted to order a list of date strings. Oh, we don't even need to. I'm being doofus. We don't even need to transform it. I just realized this goes back to always read the question. Always read the question fully. I didn't realize we didn't need to not convert it. We just need to list them in ascending order. So, okay, right, let's pay attention. So, returns a list of the dates in sorted in ascending order. Sorted might work better. Create some function, transfer the dates to more easily compare them with the sorted function. So I don't need any of this. There we go. Right, submit. Boom. Let's have a look at their solution, see if it was the same. So they did sorted dates. They did format dates, so they split that. Month, day, year, date split by dash, and then returned year, month, day. Sorted. Okay. Right, last challenge on this one. Last challenge. So, organize keywords. So by organizing keywords, documents are mapped to their relevant terms, enabling users to quickly view the keyword associated with each document. It also reduces the computational overhead of repeatedly searching for the same terms, improving the performance and responsiveness of doc-to-doc. This is useful for notebooking, research, and project management. Complete the find keywords function. It takes as an input a document string and returns a list of the keyword substrings in the document. The keywords list is being modified at the start of the code execution. Oh my gosh, I need to read this all again because it's like looking at it but not reading it. Organize keywords. By organizing keywords, documents are mapped to their relevant terms, enabling users to quickly view the keywords associated with each document. It also reduces the computational overhead of repeatedly searching for the same terms, improving the performance and responsiveness of doc-to-doc. This is useful for notebooking, research, and project management. So, assignment. Complete the find keywords function. It takes as input a document string and returns a list of keyword substrings in the document. The keywords list is being modified at the start of code execution. Turn find keywords into a pure function that does not rely on a global variable. Move the keyword, find keywords, okay? Into a pure function that does not rely on a global variable. Move keywords list inside the find keywords function, so changes the global scope to do not change this list. Okay, no problem, Captain. Okay, and then so filter the keywords to create a new list containing only the keyword substrings in the document. Okay. So return filter keywords to create a new list containing only the keyword substrings in the document. What is a document? In a document, it takes the document as string. Okay. How to use the find text history and sound variables being changed. Whoops. Find wrong one. Match. Let's try and figure it out. So filter the keywords to create a new list containing only keyword substrings in the document. Okay. So I guess, hold on. So we're going to have found keywords equals keywords. So keywords, and then we're going to do print what is document, basically. Just want to see what it is. Pull this up a little bit. So I guess we'll make this document. Document words equals document dot split, and then found keywords. So we're going to do filter. Forgotten how this works though exactly. So filter. So Python filter. I hate the docs on Python. Filter my function. So lambda lambda word equals and then keywords, and then we're going to say word in keywords, like that. Found keywords, do it like that. So expected keywords, expected index. Failed mutated input index. Excuse me. Oops, found keywords. So expected keywords, actual keywords. Whoops, did the wrong thing. Document words. So expected keywords, expected index, actual keywords. So if we fix that part, that's right. And then actual index. So key parts of functional programming, higher function, blah, 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 blah. That's right. Mutate, so fail, mutated input index. Did I? Move keywords inside. Find keywords function, so changes to the global scope do not change this list. Filter the keywords to create a new list containing only keyword substrings in the document. Be sure to return the found keyword substrings. That's the list. Oh, there's more to do. Right, okay. So I think we kind of got that. I think that's right. Oh, right, okay, I get you. Right, okay, so fix map keywords function. It takes a string document input and a dictionary document map input and returns a list of keywords, keyword substrings found in the document and a dictionary document map with the document added if needed. The document map dictionary has document strings as keys and their values are a list of keywords found in the key string. Long day. In the order they appear in the keywords list. Do not modify or return the actual input document map. So document map copy equals document map dot copy. If the document is already in the document map, return its keywords and the document map. If the document is already in document map, and then use find keywords, substrings, so found keywords, add the document and its keyword substrings to the document map. Copy it. Just run this to see what it does. Okay, so then use find keywords to get the keywords for blah blah blah. Add document and its keyword substrings to the document map. Map copy document. Oh, excuse me. Add the document, its keyword substrings to document copy. Add the document's key. Return the document's keyword substrings and the document map. Add the document. We're doing that. Add document and its keyword substrings to the document map copy. Yeah. Oh, realize I need charge. Come on. Play nicely. Here we go. Bingo. Okay, so It failed on this one. Why did it fail? So expected keywords is functional, deterministic, and memoization. Expected index is storing the results. Blah 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 blah. Add the document its keyword substring to the document copy. Check the chest view inside variables are being changed in the global scope. That's fine. I think it's just because it's not ordered. DMF. They're the right things, but in the wrong order. I know, hold on, we do it this way. Keywords, then keyword in, not that way. Yeah, one failing though. Why is it failing? So inputs, results, blah blah. So expected keywords are deterministic side effects, referential treatment. Hold on, what does document words look like? Document words. Document words. Where does it fail? So this one. And why? So inputs, storing. Okay. Storing the result of deterministic functions uses memoization to help optimize functional code. Expected keywords, functional. Oh wait, that's the one that passed. Where's the one that failed? Results are deterministic by using referential transparency and the absence of side effects. So expected keywords, these actual keywords, just that. And the results are deterministic by using referential transparency. So why did that not pass? I feel like because it's not in order, then it doesn't hit. So if we filter the list, we filter the keywords list by, we go through each word in the document words. Side effects. Referential transparency. It's only getting one. Document keywords. It's going to print. Print keywords. Keywords. So on the failing one, keywords, it's still got everything. Yeah, it's all still there. So why does it not find it? So word. Feels like this is sort of like a edge case. So keyword in keywords, document keywords, document words. Filter the keywords to create a new list. See only keyword substrings in the document. Keyword searches case insensitive. This means that lambda and lambda are the same word. So why does it fail that? Anybody got any ideas? Found keywords. Document. So just think here, howdy. See how many fall into that one. So this one does. This one doesn't. This one doesn't. And this one doesn't either. It's only the last one. So it doesn't just return straight away, it goes into this. Find keywords. Find keywords. Document split. And I don't know what's wrong, to be honest. Really struggling. So I run submit. How many fail? 3 fail. Okay, we'll learn more from the failures. Let's have a look. So this one. Expected keywords. Functional. You do something like that. Too lower. Split. I'm just going to map that map and then whoop. 1 second. Laptop's getting a little bit hotter actually. we're going to map that. Map it with lambda, lambda, word dot lower like that. Map must have these two arguments. It does, doesn't it? Whoops. There. It's always the iterable second, isn't it? Strip. Referential transparency. Ah. Can't just split them apart like that. Because there's no... Hold on, let me approach this a little bit differently. Just do it like that. Just do straight into the... Oh I'm a dummy. I can just check straight in the string. Oh no, one of them failed. What? Let's have a look at this one. So this one failed. Expected keywords, actual keywords, so it's missing functional for some reason. Ah, okay. If you do like lower like that, does that do it? Boom. Does that fix it? Yes. Such a dummy. Give me an L in chat. Or an F, wherever it is. Fail whale. I have not sorted out the Bluetooth thing yet for the video, so we're on recursion now, on chapter 4 recursion. You're probably just gonna have to bear with and try and listen through as best you can. So recursion is a famously tricky concept to grasp, but it's honestly quite simple. Don't let it intimidate you. A recursive function is just a function that calls itself. Recursion is the process of defining something in terms of itself. Right, let's listen to the thing.
Recursion is a word used to strike fear into the hearts of new programmers. It's a simple concept that just takes a second to learn how to use properly. Recursion is just when a function calls itself. Now, that might sound fairly straightforward, and it is, but it is one of the hardest concepts for new developers to learn. So don't beat yourself up if it takes just a little extra practice and a few more examples before you fully understand what's going on. Let's take a look at this simple example. We've got a function called countdown, and it takes as input n, an integer. First, it just prints n. After it prints n, it calls itself again, but only after subtracting 1 from n. So what happens if we call countdown and pass in 5 as n? Well, first, 5 is printed to the console. Then countdown is called again, but this time with n-1, or 5 minus 1, which is 4. So we go back to the top of the function. Now we'll print n, which is 4, call countdown again, this time with 3, and on forever. So we figured out the recursive part, but the problem is this function will never stop. I can't stop. It will keep calling countdown over and over and over, decrementing by 1 every time, even into the negatives. Countdown with -1, -2, -3. So what we need is a base case to stop the recursive madness. Let's add an if statement to the top of the countdown function. If n is less than or equal to 0, instead of printing n and recursing again with n minus 1, we'll just print the word blast off to the console and return immediately, again stopping the recursion. So what happens now if we call countdown with n of 5? First, 5 is printed, then we call countdown again, and that's because 5 is greater than 0, so we're not going to trigger that base case. Next, countdown is called with an n of 4. Again, we're skipping the base case because n is greater than 0, 4 is printed to the console. This continues all the way down until n is less than or equal to 0. So when n is 0, we'll enter that if statement, print blast off, and then return. And because we're returning, there will be no more recursive calls to the countdown function. So the final result is that when we call countdown of 5, 5, 4, 3, 2, 1, blast off is printed to the console. Now let's take a look at one more example. Let's say we want to write a function called dictDepth that returns the depth of an arbitrarily nested dictionary. For example, this dictionary only has a depth of 1. It has 2 key value pairs, but there's no nested dictionaries within it. But if you take a look at this dictionary, it has 3 nested levels. Melee weapons corresponds to a second dictionary, which has the key stabbies, which corresponds to another nested dictionary. A total of 3 levels. Now, because the dictionary passed into our function can be arbitrarily deep, recursion is a really good fit for this problem. So let's figure out what our function signature should be. We'll define the new function, we'll call it dictDepth, and we'll pass in 2 parameters, d, the dictionary itself, and then max depth so far, which is just going to keep track of how far into the nested dictionary we are at each level of recursion. Now this time let's start with the base case, just so we have a different way of approaching this problem. And our base case should be when there's no more dictionaries to recurse into. So if d is not a valid dictionary, for example, if it's just a number, like the number that corresponds with the Bose key, 6, then we're going to stop recursing. So we'll just add this if statement that says, if d is not a valid dictionary, immediately return the max depth so far. Okay, now we need a recursive case. We need to figure out how to go from the top level dictionary to the next level nested dictionary, or dictionaries, because there can be multiple key value pairs. So first, we'll set a current max variable equal to the max depth so far. And the purpose of this variable will be to keep track of the max depth of all the nested dictionaries at this level. Next, we need to iterate over each potential dictionary in this level. In Python, there's a .values method that we can call on a dictionary object to get every value in that level of the dictionary. Now, at each key value pair, we'll recursively call dictDepth, but this time, we'll only pass in that nested dictionary. So instead of passing in D, we're going to pass in V. We also need to increment the max depth so far by 1 because we're going 1 level deeper. Now, once that recursive call returns, it will return with the maximum depth of that sub-dictionary. So, we should track that max depth, and at the end of the loop, if that max depth is the greatest of all the nested sub-dictionaries, that will be the one we'll return. So with the first call to dictDepth, we're going to pass in a dictionary D. It has 3 layers. The first level has melee weapons as a key, which corresponds to a single dictionary. It's the only key at the top level. The second level has 2 keys, stabbies, which corresponds to third dictionary, and bows, which just corresponds to number 6. Going down into that deepest level, we've got a dictionary with 2 keys again, spears and knives. Spears mapping to 4 and knives mapping to 3. We also pass in a max depth so far of 0, just because this is the first call. So what happens? Well, first, in this initial call to dictDepth, the base case is going to be skipped because we pass in a valid dictionary. Next, we'll set the current max to the max depth so far, which is 0. And that will be overridden within our loop if we find a recursive call that returns a greater number. Now we iterate over all the key value pairs in the dictionary, which in this case is just the melee weapons key. We enter the recursive call, where we pass in the dictionary that corresponds with the melee weapons key, that sub-dictionary. We also increment the max depth so far to 1. Within that recursive call, again, D is a valid dictionary. We'll set the current max to 1, which is what the max depth so far was. Then we'll iterate over each key value pair again. This time there are 2, Stabby's key and the Bow's key. Because the Stabby's key is first, we'll start there. We'll kick off another recursive call, this time passing in the dictionary associated with the Stabby's key. We'll also increment the max depth so far to 2. We'll iterate over each key value pair. Again, there are 2, Spears, 4, and Knives, 3. Starting with the Spears key, we move into another recursive call. This time, the value 4 is not a valid dictionary, so we trigger the base case and immediately return 3, which was the max depth so far that we passed in after incrementing it. Now we are back up a level after returning 3. We move on to the next key in the dictionary, the Knives key. Again, it kicks off a recursive call. The max depth so far, again, is 3, because we've incremented it from its parent function, where it was 2. Again, D is not a valid dictionary, so we'll immediately return 3. Now, back up again in that parent function. We've iterated over both key value pairs, and we're going to return the maximum of the 2 return values, which, because they were both 3, is just 3. So that will return up the call stack again. Now we're back into the second call. There's another key for us to process, the Bow's key. That will kick off a recursive call. This time, D, again, is not a valid dictionary. It's just the value 6. So we'll return 2, because 2, again, is incremented from this call's parent function, where it was 1. Now we've iterated over each key in the dictionary, the Stabby's key and the Bow's key. The recursive call to the Stabby's key returns 3, while the recursive call to the Bow's key is 2. So this call, which will return the maximum of the 2, will return a 3. Now we're back in the original function. We've iterated over all the keys, which in this case was just the melee weapons key, its associated dictionary, and we'll return 3, and the recursion is done.
Great example. Yeah, you got to really have a good mental model there to follow recursion through fully. So let's read this all properly, and we'll take it in again, basically. So, example of recursion. If you thought loops were the only way to iterate over a list, you are wrong. Recursion is fundamental to functional programming because it's how we iterate over lists while avoiding stateful loops. Take a look at this function that sums the numbers in a list. So, define sum nums equals nums. If length nums equals 0, just return, or return num0 plus sum of nums 1, the first entry, first to the end. Oh yeah, first to the end, or 1 to the end. Print sum. Don't break your brain in the example above. Let's break it down step by step. Fair enough. Solve a small problem. Our goal is to sum all the numbers in a list, but we're not allowed to loop. So we start by solving the smallest possible problem, summing the first number in the list with the rest of the list. So first in the list plus the sums of the one after that and the rest. So recurse. So what exactly happens when we call sum nums 1 colon? Well, we're just calling sum nums with a small list. In the first call, the nums input was 1, 2, 3, 4, 5. But in the next, it's 2, 3, 4, 5. We keep calling sum nums with smaller and smaller lists. The base case. So what happens when we get to the end? Sum nums num 1 colon is called, but nums 1 colon is an empty list because we ran out of numbers. We need to write a base case to stop the madness, so return 0. The base case of a recursive function is the part of the function that does not call itself. Assignment. Dot can automatically generate various layouts for a page. There are a lot of possible layouts, so we need a factorial function to calculate the total number of possible layouts. A factorial is the product of all positive integers less than or equal to a number. Read that again. A factorial is the product of all positive integers less than or equal to a number. For example, 5 exclamation mark. Read 5 factorial as 5 times 4 times 3 times 2 times 1, which is 120. Complete factorial R function. It should be recursively calculate the factorial number. How many lessons in this one? Oh my god. What? What? Crikey. 13 lessons in recursion. Blimey. Right, okay. So, I guess the base case, so we're going to have the base case, x is just going to be a number, right? So, if x is less than or equal to 0, then return, suppose we return sum. We're going to have a sum though, aren't we? So, we're going to have a some factorial so okay. That's not going to be right. Hold on. Let me think. There are a lot of possible. Let's just do this for now. So like that, and then we're going to do basically return x. We're going to do x times factorial. It's going to be x minus 1, like that. See what it does. Fail. Oh, I suppose we don't even need to do that. Hold on. Factorial. So equals x. Is that right? Turn factorial so far. Nope. Well, let me think about this. So x is going to be just the number, so 5. So it starts with 5. We're going to need to times. We need to keep a track of that. 5. Hmm. Hold on, we need to be able to hold on to this state up here somewhere, don't we? So if we have trying to think. I know this is a fairly sort of simple problem, but that's not something I've kind of done before. So trying to think through it. So we've got factorial r. I don't use a tip, I just want to try and figure it out first try. So let's print what's happening. So let's print x. Okay. Gotta keep track of the sum along the way. How to do that? Err. Expecting 6. Right, come on, let's give us a tip. What's a small problem you can solve first? How can you go from the first value of x to the next value of x all the way down to the last value of x? What's the base case that should stop recursion since 0 exclamation mark is empty product? What should an input of 0 return? Just testing you. Oh, might have killed a machine. I've got it going all the way from down to 0. I'm gonna stop at 1. No, definitely stop at 0. What's the base case that would stop the recursion? How can you go from the first value of x to the next value of x all the way down to the last value of x? What's the best case you do to stop the recursion? Let me think. Oh, I'm gonna get trapped here. So forget the print. We know that it prints 5, 4, 3, 2, 1. We know that. But so we start with 5. X is greater than 5, so it goes to here. And then we're basically going to return x times the factorial of this. X and then the return of this. So x minus 1, so that goes to 4. So then 4 is bigger than that. It's going to be 4 times blah, 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 all the way to 0. Is it 1? Yes, it is. Okay, you don't want to stop at 0 because they're times by 0. It is 0. So then the problem is, so if x is less than or equal to 1, expecting input 0, expecting 1. What should an input of 0 return? 1, but why? Hold on. So right. Okay. Let's have a look at what they did. Is it the same? Yep, just with space. So as it loops around, so let's get it right in our head. So we start with 5. If x is equal to 0, then return 1. So it's going to be 5, and then it's going to be 5 times 4 times 3 times 2, and then when it gets to 1, no. Okay. So then it gets all the way to, we get to 0, we go blah, 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 round and round and round we go, and then x eventually becomes 0, so x equals 0, then we return 1, so it'll be 5 times 4 times 3 times 2 times 1 times 1, but 1 doesn't matter. So that's how it does it. Okay. Got that stuck in my head now. I got it. So, recursion review. Your party enters the tavern. I gather everyone around a table. I have the elves start whittling dice and get out some parchment for character sheets. Your party enters the tavern. I gather everyone around a table. I have the elves start whittling dice and get out some parchment for character sheets. Hey, no recursing. I hate explaining jokes, but in this case, you don't get the comic. The joke is that characters within the Dungeons and Dragons game are also playing their own Dungeons and Dragons game. Maybe their character's game of D&D also has characters playing D&D and so on recursively forever. I didn't quite get that. So another example. So print chars, you give it a word and an index. So then you say print chars hello 0. If I is equal to the length of word, then return. Otherwise, print word I and then print chars word I plus 1. Okay, like that. What happens if a recursive function has no base case? It will keep calling itself forever, resulting in an infinite loop. What is printed if I call print chars elephant 3? It's going to be Ella, right? No? Three. Start at 3. It's going to be fun then. Pay attention to the question, peeps. Okay, lesson 4. It's going to be a tough one to get through. Okay, so zipmap. Let's practice another simple recursive function. You may not understand recursion yet, but by following the instructions, you'll begin to grasp the fundamentals. Within doc, we need to map certain properties from one document to properties of another document. Complete the recursive zipmap function. It takes 2 lists as input and returns a dictionary, where the first list provides the keys and the second list provides the values. It takes 2 lists as input and returns a dictionary. Okay, where the first provides the list of keys and the second provides the values. Okay, here is the pseudocode. Okay, here is the pseudocode. If either the keys or the values is empty, return an empty dictionary. Base case. So if keys, so I guess we can do len keys is less than or equal to 0, or len values is less than or equal to 0, then return. That's the base case. And then recursively call zipmap on all but the first elements. From keys and values. Add the first elements of keys to the resulting dictionary and set its value to the first element in values. Return the updated dictionary. Okay, so return. Hold on. Read that. Add first element keys to the resulting dictionary. So we're going to have a dictionary to return. So dictionary equals that. It's going to get overridden though, isn't it? Let's go with it. We'll just see how we do. So then we're going to do dictionary recursively call zipmap on all the elements but the first elements from keys and values. So if how the heck am I supposed to know that? And then we're going to go keys. And then what is it? Like that. The other way around. Call like that. And then values. Same again like that. Oh, I know. I'm starting to get it now. So we wrap this up like this, and we say something like this. We go keys 0. Is it like values 0 like that? Oh my goodness. Whoops. Unhashable type set. So we're going to call zip map on all but the first elements of the keys and values. Add the first element of keys. Add the first element of keys to the resulting dictionary and set its value. Set its value to the first element, so return the updated dictionary. Okay. So here's the pseudocode. If either keys or values list is empty, return empty dictionary, the base case. So that's what I'm doing here. Oh, what am I doing? No, that's right. List is empty. Return empty dictionary, base case. Hold on, let me check. Dictionary. Yeah. So, empty. What's the thing? List. Recursively call zip map on all but the first elements. Hold on. So, This in Python. Hold on, indexing into list, that was the one. Indexing into lists. colon. List start at 1. No, not that. Need start end example. Start at 1. 1 and onwards. Dictionary. Python dictionaries. Is it because I'm trying to return? Multiple returns. So just I need to like that. So dictionary. Dictionary. Oops. Dictionary. What's that? Is that why? Doesn't like that. What's wrong with that? I'm just doing dictionaries wrong. What am I doing? Oh. Classic. What's it say in the thing? So, recursively calls zip map on all but the first elements from the key values. Add the first elements of the keys to the resulting dictionary and set its value to the first elements in values. Oh, I'm being a fool. Like that. Dictionary equals zip map. Like that. So recursive calls zip map Add the first elements of the blah 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 blah. I kind of don't know how I figured this out, to be honest. Like, I just kind of fumbled through it. So, key and values, if it's just empty, just return nothing. Dictionary equals zip map keys 111. So it goes all the way down, blah 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 blah, to like the bottom thing. Then it gets 0, so it turns. Let's have a look at that solution. Yes, they did the same thing. So the result is zip map keys 110. Yeah, same thing. Okay, so I'm trying to think it in my mind's eye, like how did it actually work? So when we run this, it jumps back up to here again. Show you zip map. So when it runs here, jumps back up to here. So it's going to do it with a small and smaller list until it gets to 0. Then it returns. Then it comes back to here and it says dictionary. This. Resolves that dictionary. Then dictionary becomes empty. Dictionary's empty dict. And then at this point, at the bottom of the call stack, just check what that is. Like, I'm just wondering, like, so I feel like keys 0 is going to be nothing, right? Values 0. It's not going to be anything. Let's have a look at running. Yeah, so it gets to 0. When it gets to less than that, then it returns non-left. Yeah, dictionary isn't anything then. Then dictionary. Okay, let's have a look at this. So I'll get this in my head. So eventually gets to there and there's none left, returns this. So here dictionary is empty. And then it goes keys 0. At that point, so keys values, they're empty, right? So nothing left. No, they're the last one. Returns an empty dictionary. So the last time it does that, it's got one thing left in it, but then it does it from spot 1 onwards. So hold on. Yeah, so 1 along, right, okay. One along. It's nothing left. Comes back, dictionary is empty. But because we're referencing the index 1, the 0, 1 is the last one that it was. And then it returns the dictionary to the zip map function above it, like in the recursion, and then so on. Cool. I get it. I'm starting to conceptualize it a little bit more now. Tricky to keep that state in your mind though. Consider the following function: countdown, blah blah blah. Which line contains the base case? If n equals 0. Yep. Which line contains the recursive call? Countdown n minus 1. What would happen if we swapped countdown minus 1 the countdown n with n for n greater than 0? What would happen if we swapped countdown n minus 1 with countdown n for n greater than 0? It'll just infinite recursive loop, right? It never stops. Whew. Oh, we're getting through this. How are we doing on time? Not bad. Not bad. So we've got nested sum. Okay. So recursion is hard for all new developers. If you're struggling, that's okay. Take your time. That's why we're doing a few extra practice problems. Prime. Assignment. In doc-to-doc, users can process files or entire directories. We need to know the total size of those files and directories measured in bytes. Due to the nested nature of directories, we represent a root directory as a list of lists. Each list represents a directory, and each number represents the size of a file in that directory. For example, here's a directory that contains 2 files at the root level, then a nested directory with its own 2 files. Here's a more complex example. So script, characters, directory, blah blah blah, which would be represented as 5, 6, 7, 8, 9, 10. Okay. Yep. Okay. Complete the sum nested list function. It takes a nested list of integers as input and should return the total size of all files in the list. It's a recursive function. Here's some pseudocode to get you started. Create an integer variable to keep track of the total size. So total let's go size equals 0, and then for each item in the list, use a loop here. So for item in st, whoops. st colon like that. If the item is an integer, add it to the total size. So if item is a, what was it, like type? I can't remember type. Can't remember. Hold on. Type. Check that. Is it something like if item is int, something like that, then total size plus equals item. the item is a list, use a recursive call to some nested list to get the size of that list and size of and that size to the total size. Return the total size when you're done iterating. So return total size. So if it's not that, and then if it's else elif item is a list, then return some nested list item. Well, that won't work. So print type print item. See, check that's working. It's not working. Python check type. Don't know that. How to do that? Oh, instance, right. Okay. So, wait, what was it again? If is instance, right, yeah. Is instance item int. Okay, that worked. So then if is instance, that's going to be blah 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 item, and then list like that. Input list, expected output 10, actual output 7. Total size. Create an integer variable to keep track of the total size. Print total size. Yeah, it keeps getting set back to 0 between everything, so how am I going to do that? If the items list, use recursive call to some nested list to get the size of that, list. Add that to the total size. So keep track of the total size. How do I keep track of the variables that go along? You can use loops with recursion, use the functional programming, avoid loops. Can be done out. Yeah, you can use loops with recursion. While functional programming avoids loops, recursion can be used outside functional programming. Use the built-in case is instance function to check if, yeah, I already figured that out, like Googling. So total size. The thing is, when it goes back around again, it gets set to 0 again. So how do I stop it from getting reset? So create an integer variable to keep track of total size. For each item in the list, use a loop here. Add it to the total size. If the item is a list, use a recursive call to some nested list to get the size of that list. Add that to the size. Oh, hold on. Total size plus equals that. Is this going to do it? Yes. Okay, hold on. Let me just delete that again. Okay, so I got it. So it's looping through this. When it hits this one, it's going to say total size plus equal to some nested list. Yeah. Okay, I think I'm getting the hang of it now. Recursion review. Okay. So hold on, my bedtime mode's kicking in. Ryan Johnson's going to tell me off. This for a minute. So recursion is so dang useful with tree-like structures because we don't always know how deep they're nested. Stop and think about how you would write nested loops to traverse a tree of arbitrary depth. It's not easy, is it? I most often use recursion on tree-like problems, file systems, nested dictionaries. If I'm just iterating over a one-dimensional list, then a loop is typically simpler, even if it's not as pure in the academic sense. Remember, the rules of functional programming are just philosophies to help you write better code, but it's not always the right tool for the job. The same goes for any programming paradigm. What makes it hard to loop over a tree? You don't know the depth of the tree, number of listed levels. You don't know the breadth of the tree, number of items at each level. Trees have too many. I think it's the top one. Yeah, you don't know how deep they go. Same thing. Imperative loops are allowed in purely functional code. Imperative loops. Not really. Loops are used often by good programmers, even though they break their code. True. Nothing wrong with just a bog standard loop. Old bog standard. Recursion on a tree. Recursion is often used in tree-like structures, for example, nested dictionaries, file systems, HTML documents, JSON objects. Let's put thing in here. So recursion on a tree. Recursion is often used in tree-like structures, for example, nested dictionaries, file systems, HTML documents, JSON objects. That's because trees can have unknown depth. It's hard to write a series of loops because you don't know how many levels deep the tree goes. So assignment. You're responsible for a module in doc2doc that can scan a file system represented in our code as nested dictionaries and create a list of the file names. Complete the recursive list files function. It accepts two arguments. Parent dictionary, a dictionary of dictionaries representing the current directory. A child's dictionary value. A child's dictionary value is a dictionary and a file's value is hold on. Parent dictionary. A dictionary of dictionaries representing the current directory. A child directory's value is a dictionary and a file's value is none. Current file path. A string representing the current path, e.g. /dir1/dir2/filename.txt. It should return a list of all file paths in the parent directory. Steps. Okay. So create an empty list to store the file paths. Okay, so file, it's got paths. Paths equals array. Use a for loop to iterate through the keys of the parent directory for parent directory. Hold on. Directory parent directory. Use the use for loop to iterate through the keys of the parent directory. Dictionaries, okay. Whoops. Use the key to create a new file path by concatenating a slash and the key to the end of the current file path. Okay. So if the value is none, the key is a file name. Append the new file name to the list of file paths. Use the key. Keys of directory. I'm just going to print just so I get the right thing here. Okay. Key key value, could do key value like that. Hold on. Blah 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 blah. For not range. Hold on. Dictionaries. Iterate over dictionary. Here we go. Hold on. Is there a better way of doing it? Key value, yeah. In Knight's items, okay. Dot items. Key to use the key to create a new file path by concatenating a slash and the key to the end of the current file path. If value is none, the key is a file name. Dot append the new file path to the list of file paths. Otherwise, the value, so child directory, recursively call again with the child directory dictionary and the new file path. Use extend to add the results to the recursive call to the list of file paths, return list of file paths. Okay. Blah blah blah. Use the key to create a new file path containing slash and the key and the key by concatenating slash and the key to the end of the current file path. Okay, so key equals current file path concatenate slash and the key. So we just do it in an F string, do F. And it's going to be current file path slash and then key. If the value is none, so if value is instance. Oh wait, no. I can just do it like value equals none. Then if the value is none, the key is a file name. Append the new file path to the list of the file paths. It's a key to append new key. Otherwise, the value is a child directory. So else child directory dictionary. So list files. What we're going to do. Return list files. Is the child directory comes with the child dictionary and the new file path. Okay. Hold on. A new file path. So value, value, and then that. And then return file paths. Almost. Need to have return here. Nope. So use the key to create a new file path concatenated with a slash and the key to the end of the current file path. Done that. New file path. If the value is none, the key is a file name. Dot append the new file path to the list of file paths. Otherwise, the value is a child directory. Recursively call list files with the child directory with the child directory dictionary and the new file path. So print new file path. Oh no, not this problem again. How do I get around this problem of hold on. Oh yeah, I forgot. So file paths. Do I extend to add the results to the recursive? Right, okay. Dot extend. Dot extend. Like that. Okay. Wait, what does dot extend do? Hold on. Extend. Extend the list by appending all items from the iterable. Okay. So print, I just want to see what this looks like. All right, okay. Right, starting to get it. I think that's it. Boom. Yes. Was their solution the same? Kind of. So file list. The key in parent directory. What are they doing? New file path, basically the same as what I did. Current file path, like, yeah, they just do without the F string. Value equals parent directory key. All right, okay, so they did it that way. Parent directory, so parent directory key. Okay. If value is none, right, I keep forgetting to use like the is thing. Then append, otherwise extend list values, blah, blah, blah. File list. Yeah, that's basically exactly what I did. Oh, nice. So, again there. We're almost at the end of this. We've got 3 challenges in this one. I think this might be all we get through tonight. Dangers of recursion. Recursion is great because it's simple and elegant, often being the most straightforward way to solve a problem. But there are some things to watch out for. Stack overflow. Each function call requires a bit of memory, so if you recurse too deeply, you can run out of stack memory, which will crash your program. This is what the famous website is named after. If you don't have a solid base case, you can end up with an infinite loop, which will likely lead to a stack overflow. Recursion, especially in a language like Python, is often slower than a for loop because each function call requires some memory. Tail call optimization can help with this, but Python doesn't support it. Tail call optimization, what's that? ExeScript 6 offers tail call optimization, where you can make some function calls without growing the call stack. This chapter explains how that works and what benefits it brings. What is tail optimization? Roughly, whenever the last thing a function does is to call another function, then the latter does not need to return to its caller. As a consequence, no information needs to be stored on the call stack, and the function call is more of a go-to, a jump. This kind of call is named tail call. Not growing the stack is named tail call optimization. Let's look at an example to better understand tail call optimization. I'll first explain how it's executed with TCO, and then without TCO, then TCO. Okay. So function ID x return x. Function f a constant b is a plus 1 return ID b. Console f2, which is c. Normal execution. Let's assume there is a JavaScript engine that manages functions calls by storing local variables and return addresses on a stack. How would such an engine execute the code initially? There would be there are only global variables ID and f on the stack, global stack frame. The block of the stack. Hold on. Oh yeah. The block of the stack entries encode the state's local variables, including parameters, of the current scope, and it is called a stack frame. In line C, f function is called. The location to return to is saved on the stack. Then f's parameters are allocated and the execution jumps to its body. The stack now looks as follows. Called stack frame of f. There are now 2 frames on the stack. One for the global scope bottom and one for f function top. F stack frame includes the return address line C. Step 3, ID is called in line B. Again, stack frame is created and contains the return address and ID's parameter. In line A, the result X is returned. ID stack frame is removed and execution jumps to the return address line B. There are several ways in which returning the value could be handled. 2 common solutions are to leave the result on a stack or to hand it over to a register. I ignore this part of execution here. The stack now looks as follows. Yep. And in line B, the value is returned to F's caller. Again, the topmost stack frame is removed. The execution jumps to the return address line. Line C receives the value 3 and logs it. So tail call optimization, same bit of code. If you look at the previous section, then there is one step that is unnecessary. Step 5. All that happens in line B. Line B. Yeah, we already got line B there. All that happens in line B is that the value returned by ID is passed on to line C. Ideally, ID could do that itself and the intermediate step could be skipped. We can make this happen by implementing the function call in line B differently. Before the call happens, the stack looks as follows. Yeah. Stack frame for F. If we examine the call, we see we examine the call, we see is the very last section in F function. Once ID is done, the only remaining action performed is F function is to pass ID's result to F's caller. Therefore, F's variables are not needed anymore, and the stack frame can be removed before making the call. The return address is given to ID is F's return address line C. During the execution of ID, the stack looks like this. Then id returns the value 3. You could say that it returns the value for f function because it transports it to f's call line C. Let's review the function. Call it in line B is a tail call. Such a call can be done with 0 stack growth. To find out whether a function call is a tail call, we must check whether it is tail position, the last action in a function. How that is done is explained in the next section. Okay, we're not getting into all that, it's way too much depth. But anyway, which is typically more performant in Python, a regular for loop? Okay, we've got 3 challenges, then that's the end of the night. God, these chapters are long. It's going to take us another couple of streams to get through these. So count nested levels. In doc-to-doc, we might have documents nested inside other documents forming a kind of tree. You know how crazy docx files can get. Anyways, we want to find out how deeply nested a given document is. Complete the count nested levels function. Loop over document ID in the nested documents dictionary. So for documents, let's call ID, ID in nested documents. If the current document ID matches the document ID, return its level of nesting. Okay, so if document ID is equal to target document ID, then return level. If the target document ID is not found, else recursively call count nested levels on the current document ID and increment the level. So I guess what is it? So count nested levels. And we're going to return that. What's it going to be? If it found the tag document, we return blah blah blah. So tag on the current document ID and increment the level. Okay, so document ID. Critical on the current document ID and increment the level. So nested documents. Oh wait, no, I'm done. Document ID, target document ID, and then level plus equals 1. If the target ID does not exist, the function is to return -1. This is gonna +1. Int object is not iterable. Nested documents. What? So it's going to be nested documents like that. If the target document ID does not exist, the function should return -1. If the target is not found, request we call if Found target to return it. Returned level was that, and then I guess if returned level, then return level, else return -1. Is that right? Crap, completely balls that up. Input document ID 9, expecting 4. So print found, and then it's document ID. Otherwise, recurse, and then I guess document ID. So expecting to recurse 1. They probably, yeah. If the correct document is return that, yeah. If the target document ID so we call on the current document ID and increment the level. If it found the target document ID, return it. If the target document ID doesn't exist, the function should return -1. Now how do we check that? One, two, three, 4. Okay. Document ID. call count nested levels on the current document ID and increment the level. Whoops. Got me stumped. Struggling now, gotta admit. If the target document is not found, return its level of nesting. If the target document is not found recursively, so it didn't find it, go to here, recursively call count nested levels on the current document ID. I mean, it used to be like that, right? Yeah. If it found the target document, it should return it. So it should return -1. It's that bit I can't quite get. I think it's right. It's just this bit. So like, found if found equals if found so what is what's found So if found is equal to none, then return -1, else return found. Crap. I'm going to need a hint for this one. If the target document ID is not found, recursively call count nested levels on the current document ID and increment the level. If it found the target document's ID level, return it. If the target document ID doesn't exist, the function should return -1. I'm struggling. Loop over the document IDs in the nested documents dictionary. If the current document ID is equal to target document ID, then return its level of nesting. Else, if the target document ID is not found, recursively call counting nested levels on the current document ID and increment the level. If it found the target ID's level, return it. How do I check that? Oh, I'm not sure. I'm going to have to ask Thingy Boots for help. What's wrong with this Boots? Game the fish. You're running counting nested levels to recursively dive into the nested structure, which is good, but here's the catch: you're immediately returning from the else block after the first recursive call whether the target was be found or not. This prevents attacking the aggressive addition. What would happen if target document ID is in a later branch and not within the first explore branch? While you are comparing found equals none, why are you comparing found equals none and return -1? This means the function effectively expects none to indicate failure. However, the instructions describe returning -1 if the target ID was not found. Let me ask you this. How can you ensure that recursion continues down through all branches before concluding whether the target document ID is truly missing? Should you really return the level right away, only after verifying all paths? Yes, after verifying all paths, but how do I do that? Okay, hold on. Uh, hmm. You're on the right track, apprentice, but there's still a small issue that could disrupt your recursive spell. Look closely at your else block. Notice that you use and return as soon as the recursive function is called. This means your loop will stop after the first item is processed. Even with the correct target document ID is not found in the branch. Let's pause and reflect. What happens if target document ID is not found in the first branch explored by the for loop? Should you halt the entire function at the first branch, or should you allow the loop to continue over the branches? You want to continue through all the necessary... Right, okay, try that. How might you modify your code so the recursion explores all branches before deciding what to return? Oh, I'm getting really desperate now. Hmm. Let's this. You're very close now, my determined friend, but there's still an oversight preventing the spell from working as intended. In your current code, you're calling the function recursively with this. However, you're not returning the result of the recursive call. Without return, the result of the recursion is computed but then ignored. Leave your function with no way to propagate the discovery of the target document ID back up the recursive call. Here's the critical question to guide your thinking. What should you do with the value returned by the recursive call? Should you discard it? Should you test it to decide what the function ought to return? How might you store the result of the recursive call and decide whether or not to return it? So I guess result equals that. I guess print result none. So I guess if this is what I had before, like if result is equal to none, then like so then return result. What? No, I didn't think that was right. Okay. It's one else return result. Come on. Two that it failed. Input document ID 20. It's not handling the -1 ones. Else return -1. Nope, it's not that. Like I don't think I can do this. I'm just gonna have to ask for the answer. No. How might you store a result of the recursive call and decide whether to return it? So I've stored it. It's killing me. I'm gonna have to show. Oh no. Let me see if I've got any things to open. Open chest. Do I get a seer stone? Nope. Hold on. I know, I lost all my things. Come on. Can I buy one? Right, so if yeah, that's what I did. So found level. So yeah. So nested documents, document ID, tag ID plus 1. That's what I did, yeah. And if found if found level is not equal to -1, return the found level or return. So close, so close. So close, so close. Dang it. Right, well, we got two. Let's have a little look at how difficult these are. Tackle this one. This won't be the last one for tonight. Dot to doc, we need to be able to reverse strings. Our bad word detection algorithms need to work on those crazy teenagers who write unpleasantries backward to try and get around our filters. However, being an ex-Haskell loving university professor, our team lead has asked us to implement it using recursion instead of a loop. Assignment: complete reverse string function. It should take a string as a parameter and return the reverse string by recursively reversing the substrings inside. Your function should recurse once for each character in the string. Okay, so just going to return s.split and just see what it does off the bat. So expect actual output, blah blah blah. Okay. Recursion instead of a loop. Complete reverse string. So how would we be our team is asked to implement it using recursion instead of a loop. It should take a string as a parameter and return the reverse string by recursively reversing the substrings inside. Your function should be able to recurse once for each character in the string. So functional program. Okay, right, I get you. Okay, let me think. How can we do that? So in recursion instead of a loop. Is this a one-liner? So we're going to do reverse string. We're going to do s dot split. We're allowed to create variables and stuff. Implement using recursion. So I guess like current score char equals s0. Okay, so it just gives us the first letter. All right. Let me think. We're gonna have to have something keeping track. Gonna have to use a loop, really, aren't we? Recursion instead of a for loop. I say reversed string. So we're going to be reverse string dot append reverse string append reversed. So then we're going to do if we're going to do S1 if so like if S so length S is less than or equal to 0, then I guess return S else so we're going to be reverse string and then it's S like one like that. Actually, reversed. Oh wait, hold on. I think I got it. Reversed equals S0. Reverse string is reversed equals that. Is that it? Oh crap. Whoops, like that. Index is out of range. Hold on. Python index append to string. Python, what was it? Index is our range. Python string index is out of range. Print S0. Come on. Come on, come on, come on. What? What am I doing wrong? Come on. Reversed equals that. Oh, not that. Ah. Come on. Oh, stop doing that. My brain's getting mushed. Right, yeah. I'm gonna have to call it quits soon because I'm not thinking straight. String. Python add to start of string. We're just missing this very simple thing. equals plus reversed. Oh, come on! That's that keep. Oh, stop doing that. What am I doing? What am I doing wrong here? Right, so we start off with an empty string. Start off with an empty string. If the length is less than or equal to 1, ow, that really hurt. No, it's got to be. You got to keep track of it as it goes along, so you can't have any returns in it. Oh no. Hold on. Reverse over reverse equals. God, I'm losing my mind over this one. So we start off with an empty string. If the length is less than or equal to 1, so if there's only one letter left, we just want to. This is the problem, though. Because I'm avoiding a for loop, I feel like if I'm going to ask this question, it's just going to. Come on, Boots. Right. Tell me what's. Hold on. Can I use a loop? Yeah, let's have the fish. I see your question, young coder. While loops are indeed magical tools, the assignment specifies for recursive solution. However, being asked blah 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 blah. Do you want to know about recursion? No. This is one portion. How do you split this into a small problem plus one operation? How do I track? How do I track the already reversed letters? In recursive function, we don't need to explicitly track previous results like we would in loop share. I know. So the magic blah blah blah. Take the first character P, reverse the rest of the string. Then put the first character at the end of the reversed substring. So if we know that reverse string gives us nothing, then reverse nothing. The recursive call builds up the solution as they return, with each level adding its contribution. Would you like to try and implement this approach? Here's my attempt. Don't laugh, Boots, okay? I know it's pathetic. You're on the right path with the recursion structure, but there's one key piece missing. Let's trace through your current function, what your current function does with ABC. For ABC, it calls reverse string. BC. For BC, it calls C. For C, it returns C, base case. Then BC returns C, basically. You didn't add the first letter. You see, the issue is that you're recursively getting the reverse substring, but you're not adding the first character to the end of it. Remember our strategy. First is S. Oh? Reverse the rest of the string, S1. Add the first character SO at the end. What? Oh, am I dum-dum? Have a look at how they did it. If length of S is equal to 0, return S. Or return reverse string. Yeah, okay. Dang it. Right, let's see. We're at the end of the night. Let's see if we can figure out this last one then. Then we can break recursion and then get back to things, function transformations, and we'll go from there. This is a lot later than I was planning, but no matter. Oh, nice. Twitter just bombed out because we said it was going to finish at 11, so it just stopped at 11 o'clock. It's nice to know. But anyway, in doc we have search function to find the longest word in a document. Complete the longest word function without a loop. It accepts string inputs document and the optional longest word, which is the current longest word and defaults to an empty string. Check if the first word is longer than the current longest word, then recur for the rest of the document. Check if the first word is longer than the current longest word, then recur for the rest of the document. Ensure there are no potential index errors. Assume that a word means a series of consecutive non-white space characters. For example, longest word, how are you? Should return string you. So I guess first score word is going to be a document.split and then 0. And then I guess for now we can just do first word and just see what it does. Yep, either, okay. So check if the first word is longer than the current longest word. So I guess if first word, hold on, length, first word is longer than the current word, then recur for the rest of the document is greater than length of the longest word, then find longest word, and it's going to be hold on, split like this. So go words equals that document split the first word, and then it's going to be words, and then one onwards, and then longest word past to it, and then check this. Ensure there are no potential index errors. What's this do? Document that split. List to string Python. Join. Words. Python list to string. Hold on. How do you just Python list to string? Accent. Join. So I guess if length words is equal to 0, then return then just return. Expecting wallpaper, got either. So first word. So longest word. Check if the first word is longer than the current longest word, then recur for the rest of the document. So on words is 0, then just return longest word. Then get the first word. It's that, then I guess well done. If the first word is greater than the length of the longest word, then longest word equals first word. Yeah. Else longest word was that. Oops. Struggling. You know what? I'm going to leave this for another day. Getting pretty difficult, and I want to crack at it on another night where I can think straight. Don't want to just kind of giving up in it. So, thanks everyone for coming down for watching. I hope you had fun watching me struggle miserably through that. Terrible. But we hope you don't make the same mistakes that I do and stuff, and you can learn. We'll crack that one at some point. But for night, say good night. Come